Physics 123, sections 1 and 2. This will be lab 2, lab, the lab for week 2. And I'm covering the part 2 of the lab for week 2. In that lab, they're going to want you to draw a graph of the position of a ball fired out of a cannon. And we're going to make some assumptions that the velocity of the ball coming out is very consistent throughout its travel, so therefore its position as a function of time should look like a straight line. A straight line, if you recall, can be written in this format. Y equals mx plus b. Y is the position of the ball at any given time. Y is the, my gosh, let me not get ahead of myself. This is just a straight line. So this is how y and x correlate to each other. M is the slope, which is just basically, here's your line. If this is the x-axis, that's the y-axis. The slope is just the change in height divided by the change in its horizontal travel. And then b is the y-intercept. That's this point right here where it crosses this y-axis. Okay, so we're going to write a formula for the travel of this ball but in position x. We'll say x is its position. So it's a direct correlation. So this x position would correlate to the y. The speed of the ball right here, which is a ratio, just as this is a ratio, is the slope times time. Time here correlates to this part, x, plus some initial position, which would be another value in centimeters, which would correlate to this. So basically now, instead of having it look like, this is x and that's y, now we have time, now we have position, we're going to get a straight line, and then we can determine certain things, like, for example, what was the initial position? It's where this line goes through the y-axis, for example. There's various things. Or what's the velocity? It would be the slope. What is the position at any given time? You plug in the seconds here and you get a position. So let's look at that lab. I'll do a little bit for you just to help you along. Here we go. By the way, do you want to move our lab to Friday? Because by Friday you will have gotten the theory from Professor Simonson. Or do you like it the way it is? Give me some feedback. Okay, so this is part 2. So we're doing Introduction to Motion Graphing. So let me just do a little graphing for you. What I got here? How much time do I have? 3 minutes? We're doing good. Okay. So what we're going to do is we're going to fill out this chart. And as we're filling this chart out, it will spontaneously be drawing a graph for us. You can click on these things and you can change those values, but they're already set up correctly. So, which column correlates to which part of the graph, so you can change that up. So you have things you can do to change it up. But it's all set up for you right now. So let's just do a couple of places here. I'll get the ball to where it's kind of showing. We're going to plot its position versus time. So I'll just go right here. I'll start there, get my toolbox down, get my ruler, line it up right there, right about there, get my stopwatch out, reset it to 0, boom. Okay, now I move it forward one frame. I can either hit this, or I can hit my keyboard, the right arrow, either or. So I'll just move it forward one frame, boom, one frame. It went forward, we'll say roughly 7. I'll just say it went forward 7 centimeters. Okay, and that was a time of 0.00038. Make sure you get your number of zeros in there right. You'll go crazy if you don't do it right. Okay, now we'll move it forward again. Another bump. Okay, 0.00. Right. 0.00077, and that would be a distance of, we'll say, I don't know, 15 and a half, or I'll just say 15. I'm making it rough, okay? Now I want you to fill out the whole thing. But at any rate, what you'll see is that it's creating. Oh, I got to hit enter. Boom. Okay. What it did is it created this graph. So I got 2 points. You'll ultimately have 5 points on yours. If I were to go like this, see this bad boy up here? If I go click, and then I say curve fits, I'll put a straight line to it. So you go down, and it's y equals ax plus b. Click, done. Here's the actual formula for the line. So a equals 2 times 10 to the 4th power. Okay, so it's roughly 4,000. I'm sorry. So that means there's roughly 2,000 centimeters per second. That's the speed. It's got a plus or minus of infinity. You're going to have a different number than mine because I didn't put enough points on. And then b is the y-intercept. So it says that the y-intercept, but it should perfectly be 0. This figure down here, root mean square error. I don't know if they care that you know about that yet. But essentially, all these things that you're going to be writing up. The only thing I really care about is you get it in the right format. You know that you don't have to do the plus or minus. You don't have to do the error when you're writing up the question below and you're answering questions. And I know everyone's going to get a slightly different answer, so that's part of it. I understand that already. So as long as you get close, you just answer these questions and you're basically done with part 2. Again, the theory of this, now, granted, you'll have like 5 points on here. You could do more, by the way. I think you get up to, maybe you get at least 12 different frames from here to there. I don't know. If you go all the way across, maybe it's 12 frames. Let's see. Curious. Let's see here. 1, 2, yeah, you get at least 12 frames. You want to do 12? That's fine. I don't care. But at least fill this up to 5. You get a bunch of different points. If you have any questions, please call me. Okay? Don't let this stuff destroy your life if you get stuck on something. Okay? And if I forget to fire up Zoom for my open office hours, please call me. I just might be distracted. I might be sitting at the computer and just simply didn't see what time it was, or I lost track of what day it was. So, we can all help each other here, okay? And now I'll do another lecture for part 3, just to hopefully, move this along, okay? Have a good day. And again, let me know, do you want to move our class back to Friday, or do you like it where it is? Am I giving you enough explanation, enough theory for you to do this? Or do you want to, wait till you get a little more explanation for Dr. Simonson, okay? Thank you.